All right, so graphing cubic functions. Parent function for a cubic is f of x equals x cubed. It doesn't have any a, b, h, or k. This is what the graph looks like. It makes that little kind of squiggly line. The domain for the function is all real numbers. So set notation says x, such as x is an element of the reals. This right here is called interval notation. That means that the x values go from negative infinity to positive infinity. Range. Range is all real numbers. The range is that y such that y is an element of the reals. This is set notation, and again, the range and interval notation. So even though it looks like the y values or the x values aren't moving over, they slowly move over. They drop faster in the y. The zeros. Zeros means where does it cross that x-axis? So in this case, for a parent function, it has 1, 0. Only one place it crosses the x-axis at 0. When the x values are greater than 0, so we're looking at the positive x, the y values are positive. And when the y value or x values are less than 0, the y values are negative. Okay, this is considered an odd function. Now we're going to talk about odd and even functions. An odd function is if you put a positive value in for x, you get a positive value in for y. If you plug a negative value in for x, then you get a negative value out for y. That's an odd function. An even function, if you plug a positive value in, you get a positive value in. If you plug a negative value in, you get a positive value out. So the only thing that's different for an even function is that this becomes positive for that last little piece. But no cubics, they are a odd function. All right, so we're going to look at what the parent functions look like. We don't have g of x in terms of f of x. We are going to look at the fact that f of x is equal to a times x minus h cubed plus k, or it'll be written as f of x equals 1 over b times x minus h cubed plus k. Notice a is on the outside of that parentheses, so it's not being cubed, and b is on the internal piece. So please pay attention to that because it makes a difference when we're identifying what a and b are. A, b, h, and k still have the same roles in the functions. A still stretches the graph vertically. B stretches the graph horizontally. H still translates the graph horizontally, and K still translates the graph vertically. This is going to be the same throughout everything we do this year on all of our translations. All right, so the first thing we're going to do is describe how the graphs are related to the parent function. So we've gotten this function g of x. We're going to see how it relates to this one. What is it doing? So the first thing we have to do is identify this 2 value. What is it? Is it a? Is it b? Is it h? Or is it k? Well, it's inside the cubic, and it's being added to the x value. So this means this is an h. Now, we need to identify what h is. And remember, it says minus h. So the only way to make that a negative is if that h value truly is a negative, because a double negative is going to cause it to turn to a positive. So we're going to describe how it's related. This means that the graph is being translated horizontally 2 units left. And that's all we're going to write. The graph is translated horizontally 2 units left. Now, looking at the negative 2 on the next problem. We got to identify, is that A, B, H, or K? Well, it's inside the cubic, so it's inside the parentheses, and it's being multiplied, which means it must be our B value. But B says it's 1 over B. So that means this actually was negative 1/2. So our B value is negative 1/2. Because if I put a 1 over negative 1/2, remember, it just flips this fraction over and becomes a whole number. So B values can be tricky, so can H values. That's kind of why we focus a little bit more on those. So b is negative 1/2. Well, b stretches the graph horizontally, but since it's a fraction, it's not going to stretch it, it's actually going to compress it. So we are going to write that it compresses our graph. Actually, let's change that wording real quick. Compresses horizontally by a factor of 1/2. Now, notice I wrote positive 1/2. Because the b value is negative, it's going to flip it. And it's not going to flip it over the x-axis. It's actually going to flip it over the y, because it's changing your x values. And if you think about it, if we go on opposite sides of the y-axis, the x values are different signs. So this also reflects the graph across the y-axis. So we've described it, we identified what the change was, and we described it. And that's going to be key to doing what we're going to do on homework. B values can be tricky, A values can be tricky, and H. K, it's pretty generic. All right, so the next part of what we're going to do is we're going to identify the transformations of the graph that produce the graph of the given function g of f. Then we're going to graph g of x on the same coordinate plane as f of x. And f of x, remember, is our parent function. F of x equals x cubed, because we're graphing cubics today. So we have this equation, g of x equals 2 times x minus 1 cubed minus 1. I want to identify the a, b, h, and k values, because it is going to help me understand what the changes are. And I'm going to use my reference points. So my a value is 2. My b value is simply 1, because there's no change there. There's no number. H is 1, and k is negative 1. Remember, h is always that opposite sign. Now, we're going to apply these changes, that a, b, h, and k, to the reference points. Reference points for cubic are always negative 1, 0, 0, and 1, 1. So we got to look. A says that it changes the graph. It stretches the graph vertically. And it stretches by multiplying. So that means I'm going to take my y value, because that's my vertical, multiply it by 2. B has no change, so I don't have to worry about it. But I'm going to multiply each of these y values by 2. H. The h value is 1. H is a translation horizontally, which means I'm going to add 1 to each of my x values, because x is my horizontal axis. K translates the graph vertically. Y is the vertical axis, so that means I'm going to add negative 1 or subtract negative 1 from each y after I multiply it by 2. And I'm going to get my new points. So let's see. Negative 1 plus 1 is 0. Negative 1 times 2 is negative 2. Negative 2 minus 1 gives me negative 3. 0 plus 1 is 1. 0 times 2 is 0. Minus 1 gives me that negative 1. And then 1 plus 1 gives me 2. 1 times 2 is 2. Minus the 1 gives me 1. The new points are the ones I want to graph. So I'm going to go over here to where my parent function was graphed, and I'm going to go 0, negative 3, 1, negative 1, and 2, positive 1. So my change is happening here, and my graph looks something like that. And remember, it's being stretched by a factor of 2 vertically, so that shift that we see here, this dip, is not going to be as predominant on this one. All right, so make sure you take good notes, get everything copied down, and we'll practice some more in class tomorrow.